Hi, Mr. Stu.
Hey, this is Harwood. How you doing today?
Good. I'm excited about this lab.
I think it's going to be a great lab, for sure.
Yeah, it's fun to look at some of this stuff. And so what I've been doing and what Mr. Stu and I have been doing is trying to figure out how to record this for you guys. But aside from some of these mirrors that we have that I got from school, uh, everything else I just had in my house. So you can follow along and you can pause this video whenever, grab the materials that we're going to be talking about and do it yourself, because it is really cool to look at some of this stuff. What we're doing an experiment on is light interacting with matter. And as we know, light travels in waves. We've been talking about sound waves. We've seen how waves move. And then light waves, they come at us in a straight line, essentially. But when it interacts with matter, and we know matter is solid, liquid, gas, any of those types of matter, it will change the light that we see. So if you see it coming through a liquid, then that light wave coming in a straight direction will change directions based on the matter that it interacts with. So the first thing to show that is a pencil in water. And you might have seen this before. This is something called refraction. And what we see is a pencil in different forms almost, because as light is interacting with the water and light interacting with the air, it's changing direction of those waves. So I'm going to put this in front. Mr. Stu, would you like to add anything to that? Or?
So, folks, all you need for this is like a glass of water and a pencil. So you can go grab this right now if you want to and pause it, like literally right now, and go grab it, because we're going to check this out. Whoa. And you may have seen this before. Maybe it was an accident, but you can see how it almost looks like there's two pieces of a pencil in that cup. What's going on there, Harwood?
Well, so the light that's hitting the water is coming at us from a different angle than the light that's coming at us through the air. So this light, as it bounces off of us, it's actually changing direction of those light waves compared to where they're coming from here. So it looks like the pencil is cut in half, but it's not.
Check that out, folks. Check that out. That's great.
Okay. So, refraction. That is on the state test a lot, by the way. That's
what word was that, Mrs. Harwood, real quick?
Refraction.
And how would you define that in your own words?
Okay, so I would define refraction by saying that the light waves change direction and speed depending on the matter that it interacts with.
Cool.
So it's a change in direction. So that's just one way that light interacts with matter. We use light as a source of, illumination, I guess, in our homes. So, and that light will change depending on what we have in front of it too. So I did a couple of videos in my basement because it was super dark down there, and that's like the only place that's dark enough. So you have to find a dark place to do this, but this is something that you can totally do on your own too. You need a white paper cup, a flashlight, and then a metal can or a metal cup. So I didn't have any white paper cups, so I just made one with a piece of paper. Just fold it around into a cone. And then I didn't have a metal can, so I just used a metal cup.
Perfect.
So the first one, which one should we do first? Let's do this one first.
So we're going to look at two videos here. You're going to shine a light with a metal cup and a paper cup. And I guess the question is, what do we think is going to happen? And how do we use some of the vocab words that we were looking at earlier this week in this one right here, right?
Mm-hmm. So with the flashlight, I had it just resting facing up on a dark table. so just be careful because I blinded myself like 3 times. When it's pointing up at you, don't look right at the flashlight. So you can see what's going to happen. I'm going to pick up the paper cup first. So what do you think is going to happen when the light interacts with the paper cup? Let's see. So again, you could be doing this on your own.
You could do the light with an iPhone thing too. Like that's perfect.
That's a great idea.
Ooh, oh! Whoa.
So what's happening there?
Whoa.
So some of the light is being reflected back down, but the metal cup, whoops. Whoa.
Jeez. So that's like, what do we call that when all the light is not passing through something?
So, well, let's talk about this one first, since that's some of the light passes through, some of the light gets reflected back. So again, if you think about that light going in a wave, some of it is like bouncing back at you. Some of it is moving right through that matter. So if you have something that's that completely blocks out the light, like a blackout curtain, which apparently I do not have in my house. That's why I had to go in my basement. So we had opaque and translucent. Do you know the difference between those two, Mr. Sumiller?
Translucent, I would say, is like, wax paper?
That's a good one.
Wax paper is like, you can still see the light shining through, but you really can't see, the details of that image.
Right.
That's translucent. And then
And then the metal cup, it just blocks all the light. So it's not letting any of that light through. It's reflecting all that light back down to the table. And if you were under that cup, you could see all the light coming back at you. So that's why I kind of put it above, like the camera angle above too, so you can see that there was nothing coming through there at all. So that's the one video. You have anything else to add, Mr. Stu?
No, I think that was perfect. And folks, you can do that. I mean, these are things you could use. Try it out.
So this next one you might have, you might not have. It's a prism, rectangular prism. Some people, I have one of these, like a rainbow maker in my window, so it turns, and when the sun shines on it, and it, what does it do when light interacts with this? So the prism is actually, this was a way for scientists in a long time ago to study light and how light interacts with matter, because it changes the direction. You could see, because it's rectangular or triangular, I guess, it changes changes the light direction in different ways. So it can reflect in a number of different ways. And you can just see that as I'm playing with it here. You could see that sometimes you can see through this, and sometimes you can't. I'm going to start this here. Perfect. And I just used a white paper bag for this, and the rectangular prism in a dark room again. You can do this with the sun too.
So there's the prism, and you can kind of see, it's like little rainbows everywhere, right?
Mm-hmm.
Okay.
So I'm trying to get it just right. And then there you see, whoa. So
that light is almost refracting 3 different ways. Is that why that is the way it is?
That's really good. Yeah. And the speed, like we said, refraction is also the speed of the wave. So the speed, because the speed changes, we know from our Bill Nye video that different colors of light have different frequencies, have different speeds. So you can see them in all of their full rainbow glory here, because that prism changed the direction of them, and so they're coming at you in different speeds, and then you can see the different colors.
That blows my mind. So your different colors have different speeds, which is why we can see them all at this point because of the prism.
Because of the prism, yes.
That is so cool.
Hmm. Okay, cool. So this last interaction is with mirrors. Now, I got these mirrors from school. I don't expect anybody to have like a convex and concave mirror, but the concave mirror is something that you probably wouldn't. Where would you find one of those?
Concave would be like a spoon, like a
Ooh, good
so
thinking.
well, if we're talking about concave, I picture, like, I don't have a concave mirror either, but that's when you have that inside curve. So it's like a cave, like the cave is going inside, right? So concave, if you want to hold up that, like, what it's going to be different. So if you even get a spoon, put your face in it, and like maybe make it back and forth, you can see your face changing, and this is what you might see.
Okay, ready? Ready?
Yeah, I'm ready. Okay.
Whoa.
All right. Oh.
Hold on, let's look at you and me. There
What
we
are
go.
you? Oh, are we flipped up? This is like Inception. There I am. There I am. Hello. So if you hold that there, it has flipped the image because it is a concave mirror. So if you had a spoon, it would look like you're upside down. And this is when we can talk about a focal point as well. Right now, but the focal point changes that image and how the light is reflecting and refracting off that mirror.
Cool. Cool.
Woo.
The convex mirror. Mirror, you can flip the spoon around if you're using a spoon. I didn't even think a spoon. Great idea. But there's also, they use these in rear view mirrors of cars. So you can go out and check out a rear view mirror of a car. Make sure it's somebody you know so you don't look creepy. And you can, what do you think is going to happen to this image? And why do you think that they use them in rear view mirrors? So let's check out what's going to happen when we put this here.
It's like almost, ever see like a fisheye lens?
Yes.
It like blows. So it, to me, I don't know if you agree, Mrs. Harwood, maybe our viewers could say something too. Mm-hmm. It looks like the focal point, the middle of that convex mirror is almost zoomed in on the middle of your screen.
Yeah, I totally get that too. So let's try it with a regular mirror. I'm just going to flip this in front.
Okay. Huh.
Mm-hmm.
And that's like getting your same view, right? It's not, whoa.
Yeah.
Very cool.
I mean, it is. It's the same exact view, except all of a sudden now we got more. We've got a wider view here.
We got a wider view.
That's like mirror, you know?
Smaller mirror, but it's still getting the same. It's almost getting more space. It's because it's getting your window, the entire computer, the outside of your computer. And then when you put the regular mirror back, that regular mirror only really catches the screen. Right? That's interesting. Hold it the same. Wow.
Yeah. Cool.
I
guess I should have cleaned my kitchen a little bit. Just kidding. So, so those are the mirrors, which is super cool. And again, focal point, this is what you're looking at, but then all of the direction. So with another thing with this convex mirror is that you can see that the light, because it's hitting on all the full curve here, it's going to change directions in all different ways, which is why you see a ton more here. So that's light interacting with matter. What do you think, Mr. Stu?
I think that's interesting that all the things that we're using is around our home or wherever you're living. And I think you could even look at different surfaces. Like, how does it reflect off your phone? How does it reflect off a dark screen? Like, light is interacting with everything around us. It just takes a minute to get to know it and get to know why that's happening the way it is.
Yeah. And it changes the way we see things, you know?
Yeah.
Very cool. All right, guys. So continue on with this slideshow. There's some questions, it's just like follow-up stuff. And if you have any questions, check in with us. We'll be on at 2 o'clock today on Google Meet. All right. See you later.